Hello everyone. If you have been using ChatGPT, Gemini, Claude, or any other AI tool, you probably wondered at least once how does this actually work. So you type a question in plain English and within a few seconds it gives you a detailed answer. It can explain code, solve math problems, write essays, generate images, and even help you debug applications. But if you really stop for a moment and think about it, how does a computer understand language? Because computers don't actually understand English, they don't know what words means. They don't know what hello means, they don't know what recursion means. So how does something like ChatGPT give such intelligent answers? Is it searching Google? Is it memorizing every answer? Or is it something completely different happening behind the scenes? That's exactly what we are going to understand today. And by the end of this video, you'll understand how LLM work from scratch. No complicated math, no research paper, just simple explanations. Before we jump into LLM models, we first need to understand something very important, because if we don't understand this one thing, nothing else in the video will make sense. So for a very long time, this is how software worked. As a developers, we wrote every single rule ourselves. Let's say we wanted to detect whether an email was spam. So we might write rules like if the email contains too many links, mark it as a spam. If the email contains certain keywords, mark it as a spam. If the sender looks suspicious, mark it as a spam. So everything depended on the rules that we wrote. The computer wasn't actually learning anything, it was simply following instructions. This is called traditional programming. And honestly, this approach worked really well for many years, but then we started asking computers much harder questions. Questions like what is the capital of Japan, explain recursion, write me a React component, summarize this research paper. Now imagine trying to write rules for every possible question a human could ever ask. It's impossible. Language is simply too flexible. So people can ask the same question in hundreds of different ways. That's why AI had to change. Instead of writing rules ourselves, we started building systems that could learn patterns from data. That's where LLM comes in. Let's break this name into three parts because the name itself tells us almost everything. First, large. Large doesn't mean physically large, it means the model has learned from an enormous amount of information. Books, articles, Wikipedia, research papers, programming documentation, open source code, and much more. The word large also refers to number of parameters inside the model. So we'll talk about parameters in another video, but for now just think of them as billions of tiny values the model has learned during training. Next, language. This tells us what kind of data the model works with. Words, sentences, paragraphs, code, conversations, everything that can be represented as language. Finally, the model. A model is simply a trained neural network. You can think of it as a giant mathematical function. You give it an input, it produces an output. So when we put all the three words together, a large language model is simply a neural network trained on a massive amount of language, so it can predict what text should come next. Notice something very important. I didn't say it understands language like humans do, because it doesn't. It predicts language. This single sentence is probably the most important idea in this entire video. Every answer you receive from ChatGPT, every paragraph, every explanation, every piece of code starts with one simple idea: prediction. Let's see what that actually means. I want you to actually answer this in your head. The capital of France is. Most of you immediately thought Paris. Why? Because your brain has seen this sentence many times before. Now let's try another one. React is a. Most developers would answer a library. Again, prediction. One more. 2 plus 2 equals 2. Everyone immediately thinks 4. Your brain is constantly predicting what comes next. And that's exactly what an LLM does. Not because it understands mathematics like we do, not because it understands geography like we do, but because it has learned patterns from an enormous amount of text. When it sees the capital of France, the next most likely word is Paris. Then after Paris, the most likely word might be and, then it, then look at it. So one word at a time, one prediction at a time. That's how every response is generated. Now here's something interesting. We've been talking about words the whole time, but computers don't actually understand words either. To a computer, the word hello is just as meaningless as the word banana. So before an LLM can predict anything, it first has to convert our language into something a computer can actually understand. And that's exactly what we are going to explore next. So in the previous part, we understood that an LLM doesn't actually think like humans, it predicts. So every response is simply the model predicting the next most likely word over and over again. But now we have another question. If computers don't understand English, then how are they even reading our prompt? When I type explain recursion, the computer doesn't see those words the way we do. It sees something completely different. Let's understand that. So computers only understand one thing, that is numbers. Everything inside your computer eventually becomes numbers. So images become numbers, videos become numbers, music becomes numbers, and language also has to become numbers. So the first job of an LLM is to convert our sentence into something that the computer can actually process. But before converting words into numbers, there's one important step, and that's called tokenization. Imagine I give you this sentence. ChatGPT is amazing. So now if you're human, you naturally read it as a one sentence. But an LLM doesn't. Instead, it breaks the sentence into smaller pieces. Those pieces are called tokens. Think of tokens like Lego blocks. A sentence is built from many Lego blocks. Similarly, language is built from many tokens. So sometimes a token is an entire word, sometimes it's only half a word, sometimes it's punctuation, sometimes it's even a space. For example, unbelievable. So this, believe, and able. So the tokenizer might split a long word into multiple smaller tokens. Why? Because the model has seen these small pieces many times during training. And by combining them together, it can understand millions of different words. This is much more efficient than storing every word separately. Now, here's something really important. The tokenizer is not the AI. A lot of beginners think the tokenizer is making decisions. It isn't. The tokenizer's only job is breaking the text into tokens. That's it, nothing more. Okay, now we have tokens, but remember, computers still don't understand words. So every token gets converted into a unique number. Imagine a giant library, something like this, like hello 254, world 982, AI 1432, chat GPT 9054, Python 5001. These numbers don't mean anything, they're simply IDs. Exactly like student roll numbers. Imagine a classroom. Instead of calling students by name, you assign each student a roll number 15, 26, 42. So the roll number doesn't describe the student, it's simply an identifier. Tokens work exactly the same way. So hello world becomes hello 254, world 982. Now we have numbers. Great, problem solved. Not really, because the number 254 doesn't tell the AI anything. It doesn't know that cat is similar to dog. It doesn't know that king and queen are related. The numbers themselves have no meaning. So we need another step. This is one of the most important concepts in machine learning. Embeddings. And honestly, once you understand embeddings, AI starts making a lot of sense. Imagine we have these words: cat, dog, lion, tiger, car, bus. Now ask which words are similar. Obviously, cat, dog, lion, tiger. These are all animals. Car and bus are vehicles. Humans understand these relationships naturally, computers don't. So instead, the AI converts every word into a list of numbers. Not just one number, hundreds or even thousands of numbers. These numbers describe the meaning of the word. This list is called an embedding vector. So cat don't don't worry about these numbers, nobody memorizes them. What's important in this, words with similar meanings end up having similar vectors, which means cat and dog end up close together. Cat and tiger also end up close together, but cat and car are very far apart. This is incredible because now the computer has no idea what a cat actually is, but it knows that cat behaves similarly to dog, and that's enough to start understanding language statistically. let's put everything together. Imagine I type this, explain recursion. What actually happens? Let's follow the journey. We're stopping here today because the next component, transformer, is actually the brain of the entire model, and that's what we'll understand in the next video. So let's quickly summarize everything we'll learn today. So when we type a prompt, the AI doesn't read English. First, it breaks the sentence into tokens. Then each token gets converted into a unique ID. Those IDs become embeddings. Embeddings capture the meaning of words mathematically, and finally, those embeddings are passed into the transformer, which predicts the next token over and over again until a complete response is generated. So today we answered one very important question: how does a LLM begin understanding language? So, and hopefully now you realize that before AI can generate anything, it first needs to convert the human language into something mathematics can understand. In the next video, we'll finally understand the most important invention in modern AI, the transformer. We'll see how attention works, why it's called a transformer, and how it predicts every single word that ChatGPT generates. I'll see you in the next one.